Communication, navigation and surveillance, in short CNS, are the main functions that form the infrastructure for air traffic management. They are essential to ensure safe and efficient air traffic. Communication between aircraft and ground, between two or more aircraft, or to exchange information or data. Navigation is done by the pilot to steer the aircraft safely to its destination. En route, this is done primarily with satellite navigation and ground systems as a backup, but landing is still primarily done with ground-based instrument landing systems, ILS. Surveillance systems are used by air traffic control to determine the position of the aircraft. This is done with radar or multilateration. The three parts of CNS are made to complement each other. In case one part becomes unavailable for any reason, the other two parts still allow safe operations. For example, if navigation fails, the air traffic controller still can see where the aircraft is with surveillance and can give instructions to the pilot accordingly through radio communication. This is rarely the case though, and each part has one or multiple backups in place. Let's go through a typical flight and see how and where CNS systems are used. En route, the aircraft often uses satellite navigation, but it can also fail, for example, due to solar wind disturbance in the ionosphere or other electromagnetic interference. For that reason, as well as to be independent as a country, we have navigation aids on the ground. They are very important as a backup, and older aircraft also use them for primary navigation. Examples of those are the distance measuring equipment, DME, to see how far the aircraft is from the navigation aid, or the VHF omnidirectional range, VOR, which lets the pilot determine his angle towards that navigation aid. The air traffic controller monitors the aircraft by radar to maintain separation to other traffic. Instead of traditional radars, other new technologies are becoming more widespread, using automatic dependent surveillance, broadcast ADS-B. This technology uses many smaller ground stations and is more redundant, as well as less expensive.
Swiss 123, descent flight level 80.
While we all know communication by voice, the air traffic controller can send information electronically to the pilot, which can save time and avoid misunderstandings. This technology is called Controller-Pilot Data Link Communication, CPDLC. The aircraft is going to land soon, and the air traffic controller is going to direct it towards the Instrument Landing System, ILS, another vital type of equipment. It can be used for landing in any weather, like clouds and fog.
Heading 110, cleared ILS approach runway 14, Swiss 123.
While the pilot is lining up the aircraft with the instrument landing system, he can observe how it is guiding him towards the landing runway. In this short overview of an aircraft landing, we can recognize just how important all of this CNS infrastructure is.